7.1 is about ratios and proportions. In problem 1, we're going to write a ratio. They talk about this bonsai tree is 15 inches tall, and a tree that they wanted to compare it to stands 118 feet tall. What is the ratio of height of the bonsai tree to the height of the other tree? Okay, so when we have inches and feet, we have to have the same units. So I want to convert to always the smaller unit, and when we do that, we're going to do some sort of what's called a unit analysis here. So 118 feet over 1 equals, and then we want to make sure that our units cancel. So 1 foot, and this gives me 12 inches in 1 foot. So the feet cancel, and now we would have the proper unit. 118 times 12 is 1,416 inches. Okay, so if I'm going to write this as a ratio from bonsai to height of the tree, I'm going to put the height of the bonsai, which is 15 inches, on top of the height of the tree, which is 1,416. Okay, and then you would go ahead and just reduce it, and you end up with 5 over 472 is my ratio. Okay, problem 2 talks about buying pots of tulips and daffodils to sell. It's some sort of fundraiser, and I feel like writing it all out. They plan to buy 120 pots of flowers. The ratio of tulips to daffodils is 2 to 3. How many of each should they buy? Remember, when something's in a ratio, it's multiplied by the same factor or a common factor. So we're going to call that factor x. So our ratio is really 2/3, but it's 2 times that x over 3 times that factor x. Okay, and we're talking about trying to buy 120 pots. So I'm going to take each one of those, 2x plus 3x, and set that equal to 120. 2x plus 3x is 5x. That equals 120. Divide by 5. That common factor that we have here is going to be 24. Okay, so to find out how many of each they should buy, I need to take the 24 and plug it back into my ratio there. So 2 times 24, which is the number of tulips, is going to be 48. And 3 times 24, which is the number of daffodils, is going to be 72. So that's how many of each kind they should buy. Problem 3 talks about the side lengths of a triangle are an extended ratio 3 to 5 to 6. The perimeter equals 98 inches. Well, let's draw our picture. It doesn't matter what the triangle looks like, but we're going to draw a picture here. You see that our side lengths are 3 to 5 to 6. And being a ratio, that means it's going to be multiplied by a common factor, which is x. Okay? So the fact that they give us the perimeter is pretty huge. When we find perimeter, all we do is we add up the sides. So 3x plus 5x plus 6x equals 98. Well, let's go ahead and solve. Add them together. That gives me 14x equals 98. Divide by 14, x equals 7. Okay, but here's what we have to understand. What is it asking for? What is the length of the longest side? Well, between 3x, 5x, and 6x, the longest side here is going to be 6 times x. So my longest side is 6 times 7, which is going to be 42 inches long. Problem 4 talks about solving proportions. Okay, and this is what I left out the property of it, but when we have things equal to each other, remember you can always cross multiply. As long as there's an equal sign between them, I can cross multiply. So 5 times x is 5x, 6 times 4 is 24. Okay, now to go ahead and solve, I'm just going to divide by 5. And again, x equals 24 over 5. And I would just leave it like that. Okay, if you want to make it a decimal, I think that's about 4.8. Okay, but 24 over 5 is fine. Same thing here. Cross multiply when there's an equal sign between the two things. 9 times y is 9y equals, and again, 3 times the y plus 4. Make sure you write it like that so you know that you've got to distribute the 3 to both of those things. 9y equals 3y plus 12. Let's go ahead and solve. Subtract 3y. That gives me 6y equals 12. Divide by 6. We get y equals 2. the key concepts here are the properties of proportions. And I kind of threw these up here so you can see. All that matters is that you keep the cross multiplication consistent. So A over B equals C over D is equivalent to, I can just go ahead and flip it. Why? Because B is times C. So see, if I look here and I cross multiply, B times C, it's the same thing over here. Same thing here. And 2, A over B equals C over D is equivalent to A over C equals. I don't really need to remember all this stuff. As long as my cross multiplication is consistent, B over C and B times C, it's all the same. So when we look at problem 5 in the diagram, x over 6 equals y over 7, what ratio completes the proportion? So x over y is what they give me. Well, if I look at my first thing, what is x multiplied by when I cross multiply? It's 7. So x and 7 should cross multiply again here. So when I'm trying to fill this in, and 6 should be times the y. So y times 6, the 6 got to go up here. X times 7, the 7's got to go down there. Okay, as long as it's consistent with our cross multiplication, we're fine. So my answer here is 6/7.